So there we go. Now I can hear that you can hear. So I have a bit of a cold. So if you hear my voice go, "I'm Batman," you'll know that something kicked in. So sorry about that. So there's actually a subtitle. Oops, is this working? Not yet. There it is. Just a second. There we go. So we're going to be talking about LLMs. How many of you were here last year? Okay, how many? And the rest of you weren't. Good. I was going to say how many weren't? So I'm going to be updating what I talked about last year, reviewing a fair amount of what I talked about last year as well. So first of all, yesterday I came through Frankfurt Airport. Not only did I see my daughter there, but there was a sign 40 meters long, an advertisement for machine translation. So this was right where you come into the airport. So what a lot of people don't know is that 2024 marks the 70th anniversary of the first demonstration of machine translation. 70 years, and now we get billboards. So it's been a long time coming, and now it's everywhere. Machine translation is so much everywhere that as president of AMTA, the Association for Machine Translation in the Americas, we're trying to de-emphasize the MT and talk about just multilingual technology, because MT is everywhere, so now the question is what's next, okay? So you already heard about me, so I'm president of AMTA. I've been in MT since the last millennium. And before that, I worked in education and in publishing. So when we talk about, one thing I'd like you to keep in mind is this really great quote from Winston Churchill, and that is, "We shape our buildings, and afterwards our buildings shape us." Graphic courtesy of ChatGPT. So, and a lot of the graphics are courtesy of ChatGPT. So, and he said this right in the middle of World War II, while trying to talk about why it's important to protect architectures. Because, yeah, we invested in them, and because of this architecture, it now changes who we are. So we're going to be talking about AI, of course. And we're going to just, this is the no-duh part of the presentation. So intelligence, it's really important to think about what we're talking about when we talk about AI. And so first of all, what is intelligence? It's not knowledge, but it's the ability to acquire, understand, and use that knowledge. And of course, artificial means made by us, and it literally comes from the Latin for craftsman. Okay, so what we're talking about is, of course, the ability of a computer or any machine to do stuff that we think requires that capacity to acquire and apply knowledge. And it's also very likely going to be humankind's greatest achievement, and some people have called it the last invention, because if we get to general AGI, so artificial general intelligence, then we don't need to invent things anymore because the AI will, okay? But my point, one thing I'm going to be coming back to a lot today is don't freak out about AI. AI is a tool, okay, that is for us to use. Often when we talk about AI, we see this kind of a picture, generated by ChatGPT. So this picture, as you know, reminiscent of Michelangelo's Sistine Chapel painting. And the prompt here was, show the hand of man reaching out and creating AI. And if you look at the original, you can see how good this is. Even the cracks, this is from the original, even the cracks behind it are included. The position of the two hands are included. The one thing ChatGPT got wrong is that the hand that it pointed out was actually God's hand and not man's hand. So ChatGPT decided that they would create us. Okay, So it got that one little thing wrong, but other than that, it created a great image. So it's incredibly hard to keep up today with what's going on in AI. And it's so hard. Here's the papers, some of the papers, academic, that I've collected over the last 2 weeks that I haven't had a chance to read yet. May 31st, June 4th, June 6th, oh, that's June 5th, June 6th, boom, 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 3 papers on June 6th. Backing up to June 4th, the Google DeepMind team, these are the people who invented neural machine translation, they invented transformer architectures, have a paper out on June 4th, to believe or not to believe your LLM. So, mirroring Shakespeare, but talking about whether we should believe LLMs. And then you can't keep up. My job is to keep up with this, and it's basically impossible to do so. And then in the popular press, then the bomb hits on Monday that Apple is going to be jumping in with AI. They've been off to the side doing their own thing for a while, very quietly. And this week, the big news came out that they will be integrating AI into iPhones and a lot of the stuff they do. So if you feel like it's hard to keep up, it is. It's really, really hard to keep up. One thing that I showed you last year was that Ray Kurzweil said that our ability to develop technology, our pace of development, doubles every 10 years. And so, presuming that's true, then during the age of AI, from 1954, the age of MT, starting with that first public demonstration up till now, we're now developing things 156 times faster than we were just then, at that point. And so there we are on this scale. And then when we hit 2034, we're going to be twice as fast again, okay? So you think you're dizzy now, wait 10 years, okay? Things are just, they're developing very, very rapidly right now. It's always been developing this rapidly, meaning we're getting better at that scale. Another thing I showed last year was taking the very long view. This is a graph of the last 2 million years of technological progress. And the reason I really love this slide is because it shows that there are things that help us get better at developing the next generation of things. And then that next generation of things helps us use those older things even better and more efficiently. So if you go back 2 million years, or to the pre-industrial age, we were transforming things. We were using stone and then bronze and then iron to create tools. And as soon as we had iron tools, we're able to use those stone tools more effectively. So you can spin a wheel of stone to crush grain into flour much more easily if you have iron gears to turn it, for instance. And then as we move forward into the industrial age, we are transforming energy, wind power, steam, electricity, internal combustion engines, in order to use those last set of things more efficiently. And so we're able to then apply those advances to our own ability to advance technology. And in the computer age, we have, of course, computer power, and then in the information age, we have data. And so the big discovery is that today, data is the equivalent of stones in the Stone Age. It's the thing we use to get better at what we do. Okay, so that's how critical data is. Another thing I touched on, I'll build out the slide very quickly. I talked about Wordle last year. And Wordle, those are just 5-letter words at the top. They're not meant to scare you. Those are just 5 random, not random. Those are just all 5-letter words. But how many of you play Wordle? So for those of you who don't, you get 6 guesses to figure out what the word is. And anytime you get a letter that's in the wrong position but is in the word, you get a yellow square. And if it's a letter that's in the correct position, you get a green square. And then you have 6 guesses to try. So Last year, I also indicated that you can think about language mathematically with Wordle, particularly if you turn it, whenever you play, you get your statistics, and if you turn it on its side and you throw in your losses, you'll find out that it's an absolutely normal curve. Okay, so this is the way a human being plays Wordle. So what I did right after this event last year is that I started playing Wordle differently. Some people would say I'm cheating, but so what I did, here are those statistics turned into percentages, and this is from when I started playing through May of last year. And here's my statistics since then. And I've only been doing one thing slightly differently, okay? And just to compare the winning percentage, I was at 98, and that's basically average. Okay, it sounds great, but it's basically average. But now I'm up to 99.5% of wins. You can see that I really lucked out, and my first word was actually the Wordle word once since last year. And the amount of guesses that I needed to win went down measurably, from 4, which is average, to tending towards that side of the graph. And so all I did was I added one piece of data to every guess I took. And this is why I'm showing you this. Data helps us perform better. And that piece of data was to keep track of all of the words that have been used and never use one of those words. So whenever I had a guess, check it against all of the previous guesses. This is something a computer could do very, very, very easily. Keep a list of 2,000 words and say, okay, is my next guess on that list? Because if it is, it can't be the answer. So with that one little piece of information, I improved my performance, okay? So when we talk about data being used to get better at stuff, this is just a very simple way to think about that. So we're also going to see how data can be used in another kind of AI system, a self-driving car. So we're going to turn the car sideways, we're going to put it on a road. A Tesla has all kinds of information available to it when it's determining how to drive. That information includes a forward-facing camera that it sees all the time that goes out 150 meters. It has rear-facing cameras. It has wide-angle cameras forward. It has telephoto cameras that go 250 meters forward. It's taking these pictures all the time, and it's never distracted. Okay, it has all of this data. It has side cameras. It has rear-angled cameras. It has everything you can imagine. Now, when you're driving, you can get any one of these things, maybe, but you can't get them all at once, right? And it goes on. It has ultrasound. It has all kinds of things. It has an internet connection. And then, oh yeah, it has 2 supercomputers on board. These are redundant, just in case one fails. The other one's still doing what it can do. It has all of this information all the time, simply to make one decision. What's the next best thing I should do, Mr. Carr, to get me to where I'm trying to go? So you couldn't do that. You can look in one direction, right? You can't pay attention to all this stuff. So let's see what this might look like for a translation system, okay? So here's a sentence that you're working on, and what you're trying to decide is what's the next best step that I could take. So with an AI system that's as powerful as a Tesla is at self-driving, what kind of data could we use there? And of course, there's contextual data. So when you're working as a translator, you're not working on one sentence. There's sentences around it that you're interested in. And of course, you'd use traditional translation memory. You could use terminology. You could use style guides. You can use machine translation. You can use context analysis, saying, is there anything that I just translated that helps me translate this sentence? You can look at the stuff that's coming ahead, saying, is there anything there that offers me a clue to what I should be translating here? These are things you could use as either a person or build into a system. Synonymy analysis for a TM, generally speaking, TMs just work on the form of the word that's in the TM, but if it's a synonym of those words, that could be a good match as well. All kinds of things that could be added in to the information that a system uses. Quality estimation we'll talk about in a second. Multimodal data. Multimodal means not just linguistic data, but other information. Metadata could be who wrote this, who was the audience, things like that. And all of this information would go into a system and be processed by a computer to determine what the next best step is. The interesting thing about this is that with the exception of TMs, and with the exception so TMs are still, of course, used, and NMT is still outperforming LLMs as a translation system. Okay, but everything else here can be done by a large language model, basically. Okay, everything else that's here. So if you imagine that all of this information is available to an AI system, call it an LLM, call it whatever you want to do, it could get you to that end point of the translation that you want, and probably with very little input from the translator. So we've talked. Peter already mentioned. We've gone through this evolution of machine translation. With anybody who's been involved with it as long as I have, you've seen these three rules-based statistical, the neural machine translation. And one of them, the first, was state-of-the-art for 50 years, and then the next one, state-of-the-art for about 1/3 of that. And then NMT, state-of-the-art. It's still state-of-the-art, but we're very likely getting to the end of that, because these things are being pushed out of the way now by this idea of using large language models. Okay, so now we're going to jump into a little bit of stuff about the large language models. And I'm covering this again. Those of you who were here last year have heard some of this, but it's more important now than even it was then, because this is part of everyday life at this point. And a year ago, it was still, ChatGPT was all of 8 months old a year ago, and now we're into an age where a lot of people are using ChatGPT all the time. The GPT stands for Generative Pre-trained Transformer, and the reason ChatGPT is not the only LLM that's available. There are, at this point, hundreds of them available, because this is the one that still takes all the air out of the room when there are conversations. I will be focusing more on it. And I just want to talk a little bit about what it is. So generative simply means that these systems are designed to simply generate something with text. All it's doing is predicting what's the next best word in a sequence based on a prompt. And if you listen to a non-native speaker of a language, sometimes you can hear that they're having trouble. Their brain is having trouble deciding what the next best word is. And everyone here probably speaks multiple languages, and you know that when you're speaking one that's not your native language, you get to that point, it's like, and then you get it, okay? So an LLM is trained to predict that next best word. That's what the word, and it generates strings of words, and increasingly, as we're in the world of multimodal LLMs, multimodal meaning they're not just based on text, they're based on all kinds of data types, images, videos, computer code, anything you can imagine, you can train these things on. Then it can generate stuff that's in line with those data types. And the pre-trained, an LLM is trained to do nothing except get a picture of that data that you presented to it. Okay, so it's pre-trained the way a child is pre-trained before it gets to school to learn more specific stuff with the language that it's learned, okay? So an LLM is pre-trained in that, when you're working on an LLM, you don't have a task in mind yet for the LLM. You're training a baseline system for it. And then the word transformer comes from the architecture. You don't really need to know much about what goes on here, other than it's been around now since 2017. It was first developed. It was developed for neural machine translation. Neural machine translation is, in fact, a transformer network. Everything that's happened in LLMs since then is kind of the descendants of neural machine translation. There are a couple other things to know about. People talk about the emergent abilities of these systems. Emergent simply means that as these models get bigger and bigger, they do get good at particular skills that were not intended by the development team. A substantial one of these, and the big surprise to this community, was their ability to respond to a prompt that was not programmed in. Okay? So this is something that the systems get better. And this graph shows that with a bunch of different types of things, your performance is basically 0. And at some point, the size of the model there is at the bottom. And at some point, boom, the ability jumps up. It's the aha moment of learning for these technologies, where suddenly it's able to do something, it's able to perform something. And multimodal, I've mentioned a few times before. Those of you who have been playing around with ChatGPT 4.0, it's not 4.0, it's 4.0, and the O stands for Omni, and it's a multimodal model, and it's a monolithic multimodal model. Oh man, a monolithic multimodal model. And what that means is that you have this one big thing that does all of this functionality for you. Instead of having multiple smaller LLMs or smaller technologies that work together, you have one massive thing. I don't see a huge advantage there, to tell you the truth. I think it's probably, as we move forward, we're going to be creating systems that are more like an octopus, if you will, that you'll have one central brain, and then all of these, octopuses have a brain in each arm, and they're all connected, and it seems to work for them. And so I think these systems, we won't necessarily be moving forward with these massive monolithic systems, but multimodal simply means that the systems are trained on multiple kinds of data and can do things with multiple kinds of data. I'm looking at time, and I'm really tight here. But I am going to, if you were training a multimodal system or an LLM at all, the thing that I'd love to do is to start with a pile of Legos. And if you were to put a pile of Legos in this room, clear out all the chairs and all the people, and bring in a 4-year-old and leave them alone for 2 hours, when you came back in 2 hours, they will have built stuff. The child will have figured out that these things fit together. And then if you say to the child, "Can you build me a house?" the child will say, "Sure," and will build a little house. The child wasn't told you can build a house out of these things, but you made it possible for them. Well, they made it possible by just understanding how these things fit together. And what's learned about those blocks, and those blocks are called tokens in the world of large language models. And for every token, a large language model tries to understand how that token associates with every other token that's there. And with words, it builds up something that you can think of as a semantic and grammatical representation of the word. The computer doesn't think that way at all. It's just a big, long string of numbers. But it allows the computer to actually do mathematics on data, on words, by converting that word to a long number. And so then it can do things like look at the mathematical relationship between Canada and Ottawa, and notice that that's the same mathematical relationship as you have between Germany and Berlin. Okay, so you've established a semantic correlation not only between those two words, but have noticed, hey, and other words seem to have that same kind of correlation. And then for all of those words in a language, you build up this crazy, very, very complicated multidimensional map. And as you get into the world where you are doing that multilingually, if you were to imagine that's one language, and you just keep on adding your languages to it, you get to a point where you have a data set that is completely beyond our ability to understand. It's just way too complicated. A computer can store tons and tons and tons of data and can make associations between that data. I get better by adding one piece of data in Wordle, right? And so a computer has all of this data available to it to apply to tasks. And now, but that gets you what's called the large language model. What I was hoping that the term foundation model would be what people actually called it, because these things form the foundation of other systems, but nobody even uses the term anymore. But what I just talked about was the unsupervised training, where you dump in all of this information, and then you have a large language model, and then you can provide specific information that's generated, that you add so that the system gets better at a particular task. And then you have an adapted model. You heard about AGT today, which is a way of adding in real time, adding information that is used to produce a particular type of output. And you can train these systems to do any kind of thing based on supervised data. Supervised means here's the input and here's the output I want you to create, and not just here's a pile of Legos. Okay? So you're giving it a question and an answer, and say, learn from this set of how many questions and answers, how to do that, and use all of that information that you have from that overall information that you've generated. So seeing multimodal LLMs at work, last year I read aloud this sonnet that ChatGPT 3.5 created. I won't bother reading this. But it drew applause last year, which was the strangest thing for me, to have a computer be applauded for writing a poem, but it happened. And of course, GPT has come a long way since then. 3.5 had 175 billion parameters. GPT-4 had 10 times more parameters, more data put into it. And recently, and the context window. So how much information the system can remember about your question expanded by nearly 10 times as well. So in 3.5, it could remember up to 3,000, think of them as words, but tokens. And in GPT-4, they expanded that to 25,000. In GPT-4.0, it's 128,000 tokens. So the memory is much more advanced. And that's why now when you use ChatGPT, it says, and if you want to ask any more questions, feel free. And you can go in and you can make changes to stuff. So, and of course, it's become multimodal. So I can say stuff like, create a photorealistic image of Michelangelo's David, but use Mark Twain's head instead. And you get a stunning image, and if any of you know what Mark Twain looks like, that's him. And then you can also add information. So here I said, take this photograph of me and create an image of the man in this photograph giving a presentation of, this is getting very meta now, a presentation about generative AI to an audience of 200 people. And it did this. So it gave me more hair, but it also provides this information. It says, here's a photorealistic image of a middle-aged, thank you, man with a gray, thank you, beard, and short hair, wearing a green sweater and a plaid shirt, giving a presentation about generative AI to an audience. Now, clearly, when it sees middle-age and generative, it comes up with a word that's more like geriatric. So it didn't quite get that. But this, for people who say these systems don't really understand, I don't understand what you mean by understand if you don't think that this understands. Because it certainly understood the question, understood what was in the photograph, and it produced, basically, I should be on that side of the stage, but it's pretty remarkable. But let's not freak out, because LLMs are tools that organize and leverage massive amounts of data, okay? The leveraging is not done because the LLM wants to, but because a person, you, prompted it to do something. Okay? When we get to AGI, artificial general intelligence, that's when a system can decide that it doesn't want to do a particular activity and wants to do something else. There are people who think that's going to happen in 10 years. There are people who think it's an impossibility. But the system does not have agency, and I'm not talking about translation agencies here. I'm talking about the philosophical sense of agency, which means an LLM does not have the capacity to act independently and to make free choices based on its will. They cannot do that, okay? These are tools to be used. Okay, I'm already over time. So can I have 5 minutes? 3, okay, so 3 minutes. So in that case, I'm just going to talk to you for 3 minutes as opposed to showing you slides and skipping through things. So actually, I'm going to close your eyes for a second. I'm going to skip through to a slide. Close your eyes, close your eyes. Your eyes are still closed. This is what I want to show you. So using a workflow with Gen AI, and you've heard about AGT, strangely developed shortly after I presented this last year. But here's the idea that you have a workflow. Okay, you get source documents, you pre-process those, you segment it, you do whatever you do in pre-processing, and then you start the translation process. But instead of, the only thing you care about a translation memory, why you would care about a TM at this point is for 100% in-context matches. Anything else, you'll get a better translation from the rest of the process here. TMs are critically important as data. And I'm going to give a plug for Mike's talk tomorrow. The quality and the type of data that is presented to these systems is what we need to work on. Okay? And Mike's going to be talking about knowledge graphs, a way to offer a higher education to the pile of Legos. Okay? Maybe I just did his whole talk in one sentence. I hope not. But anyway, so what can happen here is that if there's a 100% TM match, wonderful. We'll use that. But I'm still going to check for context. We'll talk about that in a second. And if it's not a 100% match, then I'm going to create a translation prompt. I hope you can read it. So let's say we're working on sentence number 3. That's what we're translating. The translator's already done 1 and 2. Okay, they've already vetted 1 and 2. And then you have you have 2 sentences that have not yet, the person has not vetted the translation. And then you have your X number of high quality TM matches. And you present all of that information to the system saying with the prompt something like using source sentences 1 and 2 and 4 and 5 as context, translate sentence 5 using these references. And then it would create a translation for you. Because context is really important on 100% matches, you would also present the sentences around the sentence you're working on, and you would say, look at the first 2 sentences with their translations, and look at the translations that follow that, and let me know if the context of those other sentences would indicate that some change needs to be made here. Okay? And at this point, what would get produced for the translator, a QE system is quality estimation, a different neural network that does quality controls. But you would not only get high quality translations, but you could also get annotations for the post editor or the translator. Okay, so that the person would not only get a very different experience of translating, but would actually get information about the potential kinds of errors that are in the sentences that they're being asked to look at. Now, a lot of this is to say, I'm going to skip ahead once more. This is not yet happened. Oh, I do want to say, Lengu, the company that I was working for last year, has since failed. Woohoo! So we ran out of money. We did a really great POC of exactly this, where we were generating multilingual content for a customer. So there was no source language that was translated. We immediately generated things. Very simple product descriptions into 14 languages. And the result of the POC was that using a train system that my former company produced, they made 40% fewer, they found 40% fewer errors than they did using their control, which was ChatGPT. Okay, so the idea is that by training these systems with pertinent data, you can get much better at this. And so we're no longer post-editing. Everybody's a post-editor outside of translation. Translators, we should be moving on. We should be doing, language professionals should be doing other stuff. We should be working on these systems. We should be organizing these data. That's where Mike will be talking a lot about that as we move forward. And then the only one last thing I want to jump forward to, because it's a callback, is I want you to keep in mind that the thing that a computer doesn't have is imagination and intention. You have to decide how you're going to fit into the world moving forward. And because we shape our technology, and afterwards our technology shapes us, art by ChatGPT, here's Winston Churchill looking up at the mechanical Winston Churchill. Because AI is going to change us, we have to move forward with it very carefully. And this is why intention and why our imagination is so critical. We need to be guiding this where we need it to go, where we want it to go. And we also need to understand it's a computer tool. It's software. It's not making decisions for us. We're making decisions on how to use it. So I'm here for the rest of the conference. Please feel free to come up to me for questions. Join us in Chicago for the AMPTA conference. Tomorrow is the last day to submit any proposals if you have any great ideas. And thank you very, very much for your attention.
We have time for one, possibly two questions.
In my defense, last time there was no time for questions.
I can ask a question. Have you seen what Anthropic are doing with their Golden Bridge?
Yeah.
And do you think that brings us closer to understanding what's going on?
Yeah. So there's a lot of really great companies working on this stuff, and there's a lot that's going on in understanding the reasoning, if you can call it reasoning, of what's going on behind these systems. Where work is going on intensively right now is on LLMs that make decisions. So you give it information about something, and it then suggests the best path forward. Okay, that's something that's very, very actively right now being researched. That was the subject of 2 of those papers that I flashed up, by the way. But there's so much. There's so many. Anthropic is a very interesting company. There's a company called Cohere, also Silicon Valley based, which is particularly in the multilingual large language model space as well.
Are there another question? Any questions from anybody in the audience? Okay, if that's the case, then thank you. Well, one thing that's quite interesting, you mentioned your model, which is similar to AGT. We actually found that a lady called Yasmin Muslim, who was a student in DCU in Dublin, she wrote about this months before either we did anything or you did anything or whatever. It's quite interesting that it makes sense.
It makes sense, and that's the way we move forward as a species. Nobody ever has an idea individually, right? So people talk about Darwin coming up with evolution. There were several other people. If Darwin hadn't published his book, a year later somebody else would have published basically the same book. So, and that's the way things go. And Yasmin just defended her PhD. And so at DCU, so she just finished up.
So thank you. Just, Mike, could you stand up for a second so that people know who you are? Because it's quite useful that with both Mike and Jay are here, there's an opportunity to talk to people about things like LLMs, knowledge graphs, and a whole sorts of range of technology. Both these people have been working with this, with machine translation technology. They both come from a linguistic background, but have been very, very involved with the advances in that. Mike, who worked at machine translation at eBay, he worked at LinkedIn, where he was one of the first people to work on knowledge graphs at LinkedIn as well. Both of them have got quite incredible knowledge, and it's rare that we've got an opportunity like this. So I strongly advise you to take advantage of that. Shawnee has given you a half a minute extra for the coffee break. So you have to come back at half a minute past 11. But we'll allow you to be maybe 5 minutes later. But we do need to be quite close to that 5 minutes. So now there's a coffee break. You'll have seen in the program where the next set of sessions are. Richard has got his masterclass. I'm not sure where that is. Sorry? Do I want to pass this? Okay, so everything will start at 5 minutes past 11. Thank you very much, and thank you again, Jay.